welcome to everyone on this first of hopefully many to come webinars from Elop Technology. My name is Marcus Jocham. I'm head of business development at Elop and would like to welcome all of you to our webinar today. I'm delighted to welcome all the participants from different regions, different countries, and I'm saying thank you to all of you for taking the time to join us today. With further ado, let me introduce our today's speaker, which is Niklas Persson. He is head of global sales at Elop Technology. Niklas has been working in the TIC business, which means testing, inspection, and certification, for over 25 years. In various positions for several companies, Niklas held several management positions in the past, most recently in DECRA as Vice President of Global Service Sales, as said at DECRA. Welcome to the webinar, Niklas, and I would say the stage is yours.
Thank you very much for that introduction, Marcus. Kind words. First of all, I would like to say a warm welcome to all of our participants here today. And thank you for sharing this time with us. We're going to have the webinar today, the first one actually from Elop Technology, which we hope to be the first out of many in a series. Today we're going to talk a bit about why we believe that ultrasound inspection should be a part of the requirements when tendering for new concrete assets. So let's try to jump into very quickly the agenda. We're going to start to sort of show why we believe that there's a huge need for preventive approach for the concrete health and inspections. We're going to quickly look into the NDT methods out there, the pros and cons, which are the most used techniques, why the ultrasound technology should be included in new build concrete inspections, and also, of course, what are the benefits of including them. And of course, we're going to have a quick look on the Elop Insight scanner to show how we can actually be a tool for this kind of quality control inspections. We're not going to do a deep dive into technology today. That we're going to save for other forums, but let's jump into it. Every week now, if you search on the internet, there are more or less catastrophic events with concrete assets somewhere around the world. What we're looking at here right now is from Canada last year. So it's a wind turbine collapsing in a wind park of a total of 50 turbines, where the fault that led to the collapse is actually that the concrete foundation was cracked. Now, of course, the asset owners is scratching his head and wondering what about the other 49? So now that I guess it's going to be a lot of inspections on these and investigations on the other 49 foundations here, of course. But I would actually say that this could have been prevented with a decent quality control check of the concrete foundation from the beginning. They would have had a much better integrity check and also a good monitoring of the asset over time if they repeat the tests and inspections. But we are now in a world of not that many regulations and standards in place yet. We know that in some countries there are standards in place and requirements for mandatory inspections. If we look in the European Union, the UN standard is on its way to be placed, so we are moving in the right direction. But taking the wind turbine for an example, once again, the tower, the blades, the bolts to the foundation, the lifts inside the tower, if there is one, or the telfer crane, all of them, all of these parts falls under some kind of regulations and standard. So inspected when it's designed and constructed, but the concrete itself is more or less left to its destiny. So quickly, maybe looking at a few more catastrophic events around the world. If we look at your top left, we have the bridge in Pittsburgh, which is very recently, it was in January, and actually collapsed whilst President Biden was traveling to this area, to Pittsburgh, to talk about the huge infrastructure investment that he launched for the United States. So a lot of bridges will be replaced or rehabilitated. And if we look all over the world today, and especially in Europe and Germany, we have thousands of bridges, which is actually under close monitoring, of course, because they are really in bad shape, out of ages, or they are closed down completely, waiting to be replaced. And we really hope that the new bridges that comes in place, because that's going to be a lot of them in the coming decades around the world, that they actually add ultrasound inspection into the quality control once they are built. On the right top side, you can see, which I also think that many of us remembering, it's from also last year in June, where this Surfside condo, the apartment building that collapsed in Florida. First investigation points that it might be the construction and the design flaws that could have contributed to the collapse. But what's more important here is that the state of Florida is now putting more regulations for inspections in place, and also for the new build stage, to make sure that it's really quality checked from the beginning. On the bottom left, we look at the Ponte Morandi, the famous Genoa bridge. That wasn't related to lack of quality check from the beginning, I would say. This was an old bridge, almost 50 years, if my memory doesn't fail me, when it collapsed in 2018. But it was, of course, a horrible disaster, and the investigation report points that it had some design flaws, but it was based on poor maintenance, basically, that led to this collapse. However, Italy, like being sort of the concrete country of Europe, they have had a lot of incidents throughout the decades or years, which led them into being the front runner, I would say, today in Europe when it comes to regulation, standards, etc. So they do already a lot of ultrasound inspections for new build of concrete assets. Bottom right, eye cycles that you can see hanging from the roof of the tunnel. It's actually rail metro tunnel in London. Obviously, you can see this tunnel is quite old, but we have seen this, especially here in Scandinavia, in new build tunnels, not yet opened. And due to the fact that the contractor didn't manage to fill up the air gaps between the concrete walls and roof and the mounting wall, you create these air pockets. It's filled with water. Water freezes in cold climate and expands with 10%, which leads to cracks in the concrete, and you have these kind of leakage. And when you have these eye cycles hanging in a rail tunnel, it's completely useless. You cannot open it for traffic. And this can easily be checked in the new build phase if you just require it. Okay, so let's move into the pros and cons of the NDT technologies out there today, which is at least the most common ones. On top, you can see the destructive testing part. I would say this will not be replaced because it's a very good method in order to analyze the material itself and the strength of the materials. The constraints here are, of course, that you need to extract the sample from the asset and actually do a minor damage. And you need to have a third-party laboratory if you don't have a laboratory who can analyze it in-house. Moving down to GPR, or ground penetrating radar. This is by far the most used method when you come to concrete inspections. Radar is a technology that has been around for quite some time now, and I think that the reason to why it's so commonly used is because it is a scanning method. It's a rolling device, so it's really easy to use, and you can do it in a very time efficient or even cost efficient way when you do the inspections. However, as the ones of us who are familiar with non-destructive testing, there is not one method who gives you all the information. So it's always a combination of different techniques. So what GPR is superior in is actually locating rebars, metallic objects inside a concrete asset. And actually you can do the evaluation of corrosion rates, etc., on the rebars itself. So really good for that part of the inspection. It has a limited range. It cannot go as deep as everyone would like it to do. And I would say it's also not that good. You could actually do some kind of concrete thickness with it, but it's impossible more or less to find smaller cracks, smaller air voids in critical areas. And for that, ultrasound or ultrasonic is the technique for you guys. It can do deep scans, so going much deeper than compared to the radar. You can actually do all these measurements of thickness. You can identify air pockets, voids, cracks, etc. And in the end, there are, of course, some constraints even with ultrasound. Of course, it demands a 3D image to provide the necessary, to actually read the data that you collect. And if you're looking at the ultrasound tools that is out there today in the market, they are pretty slow. It's actually what we call a static point scanner. So it's more or less impractical to do larger scans. So it has been used more for critical areas, and that's probably because of the lack of time efficiency and so on. There are a few more methods, of course, as well. We have the seismic waves. It's a different kind of wave, and it's more for mapping larger scales of defects in the concrete. So obviously you don't get the same detailed imaging that you get from ultrasound, for example, or GPR. And in the bottom, you can see the X-ray, which is also a very, very good method when it comes to rebar location and actually analyze damages to rebars inside the concrete. The constraints, of course, is that you need quite some high radiation, and you need a large clearance area for people when you use it. And the tricky part here that you need access to the other side of the asset, which is not very easy in all the cases. Okay, and what about the Elop Insight scanner? Well, it is definitely a tool for quality control, as we can go in much larger areas, collect much more data than the other equipments out there today. And as it is a rolling device, it also allows us for remote deployment, which means that we could put it on a carrier, use other tools, etc. So in the future, or soon near future, we're going to see these kind of supports to the system as well. Unmatched in speed in comparison to the competitors' point scanners, as I mentioned, we can actually scan up to 0.5 meters per second, which is quite fast if you think about it, compared to what we see today. We do have the opportunity here to do a setting that we can go with a higher accuracy and then turn down the speed a bit. So we can go like 25 centimeters a second, but we could pick up a lot of data, which gives us a high accuracy and good resolution. So normally you go on larger scans, you go with high speed, and then a quick analyze, and then you go back to the areas where you have found something that you want to investigate further. Then you can go a bit slower. It actually, as you can see on top of the scanner, there is a tablet, which gives the operator the real-time 3D visualization. So he can actually do the inspection while he goes, more or less. And as already mentioned, it's very, very efficient in measuring thickness, detects cracks, voids, pockets, etc. And it actually detects rebars. And we say that rebars from 16 millimeters in thickness in diameters and upwards, we can detect, and we detect it pretty good, and we can actually locate it in different depths as well. If the rebars are less than 16, we can pick it up sometimes, but we normally say that no, then we need to use another technique to pick this up. And as you can see, what we say, our working area is up to 2 meters in depth, which means that in good conditions, we manage the 2 meters. If we go on an older asset where you can see sometimes lower quality of concrete, where they maybe have bigger rocks inside, etc., as they was pretty common like 50 years ago, then that will create some noise and disturbance for us, and we might not reach the 2 meters. But on the other hand, new modern concrete, which is a really high quality, and actually go deeper up to 2.5 meters in depth. And there's a software side to this as well. We have a cloud-based web portal, and it's very easy to use. This is where you can do your deeper analysis of the data. You can do fancy or really nice visualizations that for us who works with this, it's probably good enough, so to say, to identify and understand the heat map 3Ds. But for a client, an end client, it's really nice to do much better visualizations, which we can do there as well. And of course, by having this cloud-based web portal, it also gives the team around the inspection the opportunity to have back office analyze more or less in real time as the operator is out and scanning the asset. And just to give you an idea how it works, a very, very short video of the All right. And why do we believe that ultrasound technology should be included in new build concrete inspections then? Well, I would try to throw that back to the market out there. Why not? The technology is here now. It's available. It's, as we have heard now, it's very time efficient. So we can scan larger areas in much shorter time than before. And the question is, could the owners, the asset owners in the end, afford not to require this? Even though there might not be a regulation in place for that particular asset they're going to purchase, they have this in their hands totally by themselves to actually require this already in the tendering phase. So with that said, they are in the driver's seat right now. I'm quite sure that in the coming years, even in more countries, we will see regulations and standards requiring certain amount of non-destructive testing. As I mentioned in the beginning, it's coming, and it's coming in more and more countries, and it's going to be more and more developed like we have seen on the steel side of things in the world for the last 80 years. And of course, if you do a decent quality check of an asset in the new build phase with ultrasound, this should also, of course, be a part of the quality documents or the handover documents to the end client. If you take a railway tunnel, for an example, you have the high power lining on the roof side, you have the emergency exits with the handrails, etc. Everything is inspected, checked, documented, and being a part of the handover documents. But the concrete, not much, and especially no documents. There will be some specimen samples, as we mentioned, with destructive testing. They will look at the strength, the classification, but in most cases, that's it in many countries. Okay, so how do we prove our technology then, the Elop Insight scanning technique, or challenge it even, if you would like to prefer that? Well, we're doing field tests right now all over the place, I would say almost, but at least in Europe, and we've done some in North America as well. So you can see that we've been in Florida, doing tests on a typical apartment building similar to the one who collapsed. We have placed the system in the hands of the two major research centers in Germany, which is BAM and Fraunhofer, really well known. And this is sort of the quality stamp for any tool to be proven in the market of Germany. And with that said, Germany is Germany, and that's going to count in many other countries in the world as well, because they are very, very known. So, and the first feedback is really positive. So we're looking forward to get the reports from them. And then we've done some live demos in UK, of course. As you can see, And as we speak, we are in Italy for the demo tour that you can see in the bottom here. So we are trying to get as many interest participants in different countries collected. We pack our gear, we go down there and we do demos, and what we call is field tests is more related to where we actually go out on a real asset, preferably an old asset where we know that there are some defects inside, and just to prove and test that we can find whatever it is. Okay, so what are the benefits actually to making these concrete inspection a requirement? Well, mentioned already the steel side of things. 8 years ago, that was suffering all around the world on the steel side with poor quality. There were no regulations, no standards in place, but the end users, the owners of the steel assets were quite concerned, where they started to actually require quality control by any steel asset that would deliver to them. And that made the quality increase directly, because those ones who did know that they didn't really do a proper job, they went out of the business. And this is the message that we would like that asset owners would send right now as well, until the regulations, the mandatory inspections are in place. And basically saying that we will check your work, don't come here, cut corners. And if I was the asset owner, of course, I would like to know that my delivery, the concrete itself, is according to the specifications and the contract that we have set up and decided. And if not, this gives the asset owner the opportunity actually to already, before it's handed over, require from the contractor to the repair and fix this right away. Because you don't want to end up with a surprise detecting this while you maybe have passed a couple of years of operation of the asset or whatever, and it moves into the periodic inspection program, and then you pick this up, it's too late to do something about it, at least on the cost side of things. So you have to pay for it yourself. So better to try to actually identify and detect it already in the beginning, and request the contractor to fix it, and that will give you less problems for the future, lower cost related to maintenance and repairs, of course. And the asset owner will benefit of a longer lifetime of the asset. And also, when you do larger concrete scans already in the construction phase, that will give you a lot of data about the asset, which you save for the rest of the lifetime. And as we are talking about concrete here, ladies and gentlemen, there will always be some defects inside, like air pockets, voids, etc. But they might not be that critical. But it gives you the opportunity to monitor these kind of non-critical defects over time, of course, by repeating the tests in the future. So if we're going to summarize this, from our side, the message here today would be that the asset owners should start setting these requirements in place for their new concrete structures. We know that a lot of them are doing it, but it's by far not all of them. The technology is now in place to do this time efficient, and time efficient is cost efficient, right? So there shouldn't be a problem by investing a few more euros or dollars or kroner or whatever in the beginning, making sure that you reduce your cost over time, and especially the safety of the asset. And by controlling this or checking the quality at the construction stage, the lifetime will be extended, that we already agreed upon. And we will definitely see less catastrophic accidents, as we looked at in the beginning here, in the future with a quality check from the beginning and then a periodic inspection program in place. Lifetime cost will be lowered. And finally, the impact on the environment will be decreased. And what do I mean with that? Well, I haven't mentioned this, but it's a fact that 8% of the CO2 imprint worldwide every year comes from concrete manufacturing. So with that said, if we can prolong the lifetime of our concrete assets out there in the world, it will also benefit the environment, of course. And that, ladies and gentlemen, was everything from me presentation-wise today. And we would now like to invite you to ask questions through the Q&A box. Thank you very much.
Niklas, thank you for this wonderful and very impressive session. And I would also say again, thank you to all the participants for hearing us. We will now move on to the Q&A session, which means you can post questions into the Q&A box. As said many times, I see we already have a lot of questions in the Q&A box, so I will, time is a bit too short to answer them all. But if everybody agrees, I would like to pick some of them. And Niklas, are you ready for having some questions on your session?
I hope so. Shoot, Marcus.
Okay, all right. Niklas, the first question a participant asked is, how long can you scan with your tool?
It's a good question. And we normally get this in all our demonstrations we do, or online demos. It depends, of course. It depends on which mode you choose to scan in. And it also depends on the thickness of the concrete. So obviously scanning an asset that is 2 meters in depth thickness will collect much more data, which takes more time to process. So then we can scan shorter areas, of course. But when you look at what we see that this tool will be used at in the future is probably larger scans, of course. And you have this possibility to disable the 3D real-time visualization, that's the part that takes time to process the data to make it 3D. But if you disable that and go in capture only mode, and if you look, let's say you go out to an asset, you want to scan as much as possible, you go back home to your office, and then you process the data. In that case, we can scan like 50 meters scans, and then you stop, reset, do another 50 meter scan, stop, reset, and continuously. So you can do it really quick, and you do all the processing back office. So it depends on which approach you have. Was that clear enough, Marcus?
For me, yes, Niklas, but I guess the answer was full-scale answer. Thank you for that. And let me pick the next one, which is you mentioned something where the data is stored. You mentioned the cloud. Can you say a bit something what you mean with that?
Well, of course, we have softwares to this, right? And you saw the software in the tablet itself. This is where you have more or less full-scale software, especially when it comes to the 3D thing, where the operator actually can choose to work in real live 3D. But there is also a cloud-based web portal. And this is the place where we upload all the data. And this is a place where all the users sort of analyze, you're doing the deep analyze because you have some more features for this there. And you also can do the visualization in a nicer way for your digital reporting, which you also do inside the web portal. So there is a lot of features that you use in the web portal that is key here in the end to make it a full delivery, so to say, to the client.
Okay, understood. I guess that answered the question. There was just one question coming in, which I find very interesting, Niklas, is what is the weight you need to apply? Is it physically demanding?
Yeah, it can be. It can be. I would say, first of all, the scanner itself weighs approximately 7.58 kilos. It depends on if you're going handheld with a handheld cover on top, so to say, or not. But nevertheless, it all comes down to the surface of the concrete. And we all know that concrete is not very smooth. So the more rough surface you have, the more pressure you need to load onto the scanner. And we just say that average you need somewhere between 18 to 20 kilos in general. If you have a really rough surface, that means you're probably going to need to push a bit harder. But if you have a really smooth concrete slab, which a fine, nice surface, actually the own weight of the scanner can be enough sometimes. So, but that is and how do you know that you have the right pressure? Well, the system will tell you. So you have this information in a box while scanning that you see that you have green, which is good. And you know that you have the right amount of pressure to collect the data you need. Long answer to a short question, Marcus.
No, but I guess that hopefully makes it clear for the participant. Looking at the time, we still have a few minutes to get through the questions. Let me just pick this one, Niklas. And this is the question here. You talk about new concrete, but it's also important to inspect old concrete to calculate lifetime. Is it possible to see cracks and quality in old concrete?
Absolutely, yes, it is. That's not a problem. I mean, that doesn't differ, new or old concrete. That's not the big deal here. What I meant, my key message here is that to make a status of the assessment from day one, from the birth, so to say, will give you a lot of information for the future. Because going on to an old asset right now, we will pick up all the cracks, all the voids and everything. That's perfect. But you don't really know, have they been there from day one? Or have they been growing over time? Or was it more or less happening due to the earthquake the other month or the other year? So, and this makes it pretty difficult to also calculate or extend lifetimes. So you should have as much information as possible already from birth. And then if you find something 20 years later, it will give you much more knowledge if you knew if it was there from the beginning or not. Make sense?
It does. And may I add something from the BizDev side here? And that exactly takes you to a stage where you get to risk-based inspection and you have predictive maintenance. And well said, Niklas, I guess that answers the question. There is another question which I find very interesting from a participant. Can we expect an automatic rolling scanner development in the future, Niklas? Can you say something about that?
With automatic, I guess they mean sort of a robotic solution, right?
I would assume that.
Yeah. Well, the short answer is yes, you will. Obviously, if you look, we are looking into different setups, opportunities here with crawlers, of course. And crawlers, as we know it, is 99% on the steel side of things. It's much easier. You do magnetic wheels and you size it depending on the weight you have to carry. Same thing is here. We need to find a crawler who can carry the weight and to actually push the pressure we need on sort of rougher surfaces. But the major thing here is that we cannot use magnetic wheels, right? So we need to have a vacuum crawler. And we are actually in a couple of development projects around this right now as we speak. And we're not there yet, but we hope that we can demo the first pilot system in a couple of months. So later this year.
Okay, thank you, Niklas, for that. I do have another question which should be answered, I guess. Is the failure rate of the instrument roller high? Do you need some precautions when using?
Can you repeat the question, Marcus?
Yes, Niklas. Is the failure rate of the instrument roller high? That's one question in that sentence. Do you need some precautions when using the system?
Well, not really, I would say. Failure, no. We do see that we are having, I mean, it's a new technique, right? So we do have a few things that we need to develop and improve, of course. Those are most on the software side. And this is where we work with our new clients, early adopters that we have already now around the world. And we have a really transparent way of feeding back return of experience, basically. So good things, bad things, and we try to develop as we go. But the failure rate, no, we haven't seen a high from the system so far. It's stable, it looks good. And I mean, caution, it's not specialized caution you need to care about unless, except for normal manners and construction site safety, basically. So it's like bringing
which I guess,
yeah,
which I guess applies to any NDT technology you bring on site.
Exactly.
Thank you, Niklas. We still have a few minutes, so I would like to pick potentially 2 or 3 more. Then we need to look at the time. one question which I find interesting is what is the uniqueness of your tool? So I guess what is the USP that participant wants to know?
Yeah, okay, that's pretty easy to answer. As we heard here today, there are ultrasound equipments out there. They are point scanners, static. So speed, of course, we can scan much faster, collect much more data for the end client and users, which I already explained gives a good foot base from taking the asset into its lifetime in periodic inspections program. So speed and the amount of data, I would say. And then, of course, what we're also looking into to be able to deploy this remotely with some kind of crawler solution. That will be very difficult to do with point scanners where you have to stop whilst we can just go. So I would, if that is the USP, the 3 USPs with our system compared to what you have in the market today.
Thank you, Niklas. Last 2 ones, then we need to close that Q&A session because of the time. What is the support model? And I can only guess, Niklas, that would mean, and we get this question from many clients out there. I guess it means, how do we support our technology, our software on a global scale? If I got that right.
It's like you said, Marcus, we get this question quite frequently from clients out there. Yeah, and it's a very good point, good question. Norway, small country, we produce the scanners here today. And it makes no sense, of course, to do everything from Oslo in Norway or in Hamar, where we have our R&D and production facilities. So what we do right now is that we're signing up with distributing partners, and not only for reselling, but full service partners for service, maintenance, repairs, calibrations, etc. So the local user, the local buyer of an Insight system will have its local partner or local distributor in the area. So we will have the full support for that.
Okay, understood. Last one, Mr. Persson, is from a participant, and he asks, can we roll the scanner on surface apart from concrete? For example, tiled terrace, painted buildings, epoxy-coated flooring or bridge. So I guess that participant refers to, can we somehow penetrate coating materials and see underneath what's happening?
Yeah, good question. Basically, the technique, the secret behind the technique is actually the elastomers and the rollers, which means that we have a rubber-ish, and that's the patent part here, to make it a dry coupling. Without, everyone who works with ultrasound knows that you need to have a coupling medium like water, gel, oil or something to make the ultrasound waves enter into the material you want to inspect. Our elastomers, the rubberish wheels, is the ones who replaces this coupling. So they acts as a coupling medium. So they press, and that's why you need some pressure. They push the air gap between the material and the sensors away, and that's it. So coming to this question, the technique itself is adaptable to more or less any material. But if you would like to move on steels or composite materials, etc., you need to play with frequencies, etc. So that's not, you need a separate system for that, basically. But when it comes to paintings, coatings, I would say we have done quite some tests, and it looks good in many ways, many setups. But there is also some coatings which could be mixed up with lead sometimes, etc. And that if you have a coating like that or a paint like that, that will interfere, of course, with the ultrasound waves, which give us some noise. So I would say the answer is yes, but preferably you need to test it before you tell any client that I can do this.
And that's a perfect handover to me ending this Q&A session because of the time. We couldn't cover all the questions. We will promise to answer them in a follow-up email. And Niklas, again, thank you for that wonderful session. And just picking up what you said in the last sentence, Niklas, demos and proof of concepts are key, and we can answer a lot of questions, but often in real life the situation looks different. So we can only ask you you clients out there to ask for an online demo, for a live demo, for a proof of concept. At the end of the session, we will send out an email with where you can click on a button which takes you to our book a demo page on our website. Please use this opportunity. We will be happy to assist you on a proof of concept online demo whatsoever. And again, I want to say thank you for your time, Niklas, and also to all the participants for staying with us and being on time, which makes us happy and enables us to carry out this webinar session for the full time. And I guess we covered all of it. Hope you found this useful. And Niklas, last words over to you. And again, thank you for your wonderful session.
Thank you, Marcus. And more or less, you already said it all, Marcus. Thank you very much for your time here. Keep following us. We will launch more webinars in the future here to make it as serious as I said in the beginning. And with that said, enjoy the rest of your week, and I hope to see you soon.